Hey guys, I thought I'd just take a few minutes to work through one of the problems for you. I figured maybe I'd even be nice and work one of the last ones for you, just so you'd have an example of one that has some trig and also two equations at once. So this is actually part B of question number 6 from your homework. So this is a hunter aiming his gun at a target, which is on the same level 75 meters away. The question is, at what angle should the gun be aimed so that he hits the target? Okay, so that's what we're going to do. We're going to go ahead and try to figure that out. So let's start by just drawing a picture. So there's my gun. Here's my target. Okay, at the same level, 75 meters away, right? And he wants to fire the gun so that the bullet flies over and hits the center of the target. So he hits it right in the middle, even though we know that gravity is going to make it follow a parabola. In the first part of this question, you found out how far below the target it would hit if he aimed straight. So now we're going to see what we need to do, how we need to adjust that so that he hits the target. So let's start off by writing down the information that we have. Okay, so we've got x and y. And then we have initial position, final position, initial velocity, final velocity, acceleration, and time. Now it looks like we don't have a lot of information, but believe it or not, we really do. The initial position in the x direction is 0. It flies 75 meters, right? We know that the acceleration is 0. Okay, now in the y direction, it starts and ends at the same height. So if we say that this is 0, then my initial y position is 0, final y position is 0. I don't know the velocities, but I do know the acceleration is negative 9.81 meters per second squared. Okay, so I don't know the time, I don't know the velocities. Now, I do need something else to relate these two together. I have the displacement and I have the acceleration. I actually need one more piece of information. I'm going to have two unknowns, but the unknowns have to be related. The time's automatically going to be the same for both x and y, but the velocity is not necessarily the same. The initial velocity is constant. However, it's going to be different in the x and y directions, and so we can show that by breaking that into components. Okay, so we'll take this initial velocity, and the x initial velocity, or the initial velocity in the x direction, is going to be equal to the initial velocity times the cosine of my angle. Okay, and the angle is what I'm looking for, right? And then the height, the vertical velocity is going to be the initial velocity times the sine of the angle. Okay, so I can go ahead and put that information in now. I know that the initial velocity in the x direction is going to be initial velocity times cosine of the angle. And then here we're going to have the initial velocity times the sine of the angle. Not only do I know that, but I know that the x velocity is constant everywhere. So the final velocity is also going to be initial velocity times cosine of theta. And then the final vertical velocity, since it goes up and comes back down to the same height, is going to be the negative of what it was. Okay, because it has the same amount of time to go up and to come down. So I actually have quite a bit of information now. So now I'm going to be able to kind of put this in. Now it actually tells me in the problem, which I forgot to write down here, but it actually tells me that the gun in my question fires at 180 meters per second, which is going to be this initial velocity right here. All of these initial velocities are going to be 180 meters per second. Okay, your problem has that as well. So now that we know all of that, we should be able to put this together and get some information out of it. So first I'm going to look at the x direction. Okay, so I want a simple equation, one of our kinematics equations. If I can stay away from a quadratic, I will, just because it's easier. Since the velocity is constant in the x direction, that means that the distance it travels, okay, or delta x, is going to be equal to the velocity, the average velocity, times the time. Okay, that's just a simple equation that you learned back in 6th grade or something, right? We still use it. You may have seen it look something like this. Delta x equals v naught plus v over 2 times time. That's the way that we have seen it in class, but since those velocities are both the same thing, when you add them together and divide by 2, you just get the same thing that you started with. So let's go ahead and write that out. The change in position for x is 75, which is going to be equal to the average velocity, which is going to be 180 cosine of theta, and then that will be multiplied by the time. Okay, I'm going to go ahead and solve for time here. Or we can just leave it. It doesn't. We'll go ahead and leave it so that we can see what we need to do with y. So let's go with y now. Now y is going to be a little bit different. In this case, I'm going to use the equation of v equals v naught plus at. All right. So we can go ahead and put that information in. All right. So the final velocity is negative v naught sine of theta. So that's equal to v naught sine of theta plus negative 9.81 times t. Now you'll notice that again I have that initial velocity, which is 180 meters per second. Time and the angle are going to be my unknowns again, just like they were up here. Okay, and so if I put that 180 in for v naught, right, I'm going to take this and subtract it to the other side, which will give me negative 360 sine of theta equals negative 9.81 t. I divide both sides by 9.1, so 360 divided by 9.81. Now I didn't write the negatives here just in the interest of time, but you can see that negative divided by negative will be positive, so 36.69. So that gives me that t equals 36.69 sine of theta. Okay, so now I can take this and plug it in to my time in this equation right here. Alright, so let's go ahead and do that. I'm going to rewrite it over here. So I'm going to have 75 equals 180 cosine of theta times 36.69 sine of theta. Okay, so here I'm going to multiply 180 times 36.69, so times 180. Okay, so now I have 75 equals 6605 sine of theta cosine of theta. Now here you're going to find something very useful, which is a trig function, which hopefully you've learned before. If not, it's okay. It's in the back of your physics book. But it looks something like this. It says, and I'm going to write it right up here in this area, that 2 sine theta cosine theta is equal to sine of 2 theta. Okay, so by using this, then we can get rid of having both a sine and a cosine and turn it just into a sine. So what I'm going to need to do is divide by 6605 and then multiply by 2. So that'll get rid of the 6605. It'll give me a 2. So let's take the 75. We're going to divide by that 6605. Okay, now I'm going to multiply it by 2. So that will be 0.0227. 0.0227 is equal to 2 sine theta cosine theta, right? So I divided by 6605, multiplied by 2, that gives me this. 2 sine theta cosine theta now turns into sine of 2 theta, so 0.0227 equals sine of 2 theta. We'll do the inverse sine and divide 2. So the inverse sine of the answer, and then divide that by 2, and I get my answer that theta is equal to 0.65. And there you go. That's your angle. That's what you need to shoot at. How about that for some cookies? See you guys later.